In last few lectures of material testing and evaluation, we have discussed about the various materials used in construction like cement, sand, bricks along with their properties and tests conducted to check their quality. Now in this session we are going to discuss about another construction material called as coarse aggregate, its properties and tests. Myself, R.V. Zugdar, Assistant Professor in Civil Engineering Department, Sharda Institute of Technology, College of Engineering. Now, firstly, we will discuss about what is aggregate and what are uses of aggregate. Aggregate is a filler used along with binding material which is derived from rocks. It forms the body of concrete and reduces shrinkage and effect to manufacture concrete in economic way. It occupies 70 to 80% of volume and have considerable influence on properties of concrete. Important to obtain good quality of concrete, it requires good quality aggregates also. The aggregates are not chemically inert material. The chemically active by exhibiting chemical bond at interface of aggregate and cement paste. The securing volumetric stability and durability is because of coarse aggregate is achieved by concrete. Classification of aggregates. Aggregates are broadly classified as fine aggregates, the aggregates having larger size than 0.07 mm and passing through sieve of 4.75 mm. And the next type is coarse aggregate, the aggregates retaining on 4.75 mm sieve and less than 80 mm. This image shows the various grades of aggregates. The classification of aggregates is based on various types such as on basis of geological origin, on basis of size, on basis of shape of aggregate and on basis of unit weight. The classification based on geological origin is having two types of aggregate like natural aggregates and artificial aggregates. On basis of size there are all in aggregates and graded aggregates. On basis of shape of aggregate it is angular aggregate and flaky aggregates. And on basis of unit weight there are three categories like normal aggregate, heavy aggregate and light weight aggregates. According to geological origin, the aggregates are classified as natural aggregates which are obtained by crushing rocks, also by weathering action and by natural agencies like wind and natural stream. The rocks are disintegrated to form aggregates. The most widely used rocks for natural aggregate is igneous rock. The next type is artificial aggregates, which is not used in RCC works. Broken bricks, brick bats suitable for mass concreting, for example, foundations. Blast furnace slag is another type of artificial aggregate. It is used for precast concrete products, fire resistant but responsible for corrosion due to sulfur content in it. The next type is synthetic aggregates, which are thermally processed materials such as expanded clay and shell. These are light in weights and used for lightweight concrete. The next classification based on size is all in aggregates, which is different fraction of fine and coarse sizes. They are not recommended for quality type of concrete. And next is graded aggregate. Aggregate, most of which passes through a particular size of sieve, are known as graded aggregate. For example, a graded aggregate of nominal size 20 mm means an aggregate of which passes IS sieve 20 mm. The next classification based on shape, in which the aggregates are classified as elongated aggregates and flaky aggregates. The aggregates are said to be elongated when having length 1.8 times or 9/5 of the mean dimension of aggregate, and for flaky aggregates least dimension should be less than 0.6 times the 3/5 of mean dimension. Orient orient of in one plane with water and air voids underneath adversely affect the durability and are restricted to maximum of 15%. This image shows the flaky aggregate and elongated aggregate structure. The flaky aggregates having less thickness as compared to other dimensions, and elongated aggregates having more length as compared to lateral dimensions. The classification based on its unit weight, the aggregates are classified as normal weight, heavy weight, and light weight. This chart shows the various properties like specific gravity, unit weight, bulk density, along with example of these type of aggregates. The normal aggregates or normal weight aggregates having specific gravity ranges from 2.5 to 2.7, unit weight of 23 to 26 kilonewton per meter cube, bulk density 15.20 to 16.80 kilonewton per meter cube, and the best example is sand. For heavyweight aggregates, the specific gravity ranges from 2.8 to 2.9. The unit weight ranges from 25 to 29 kilonewton per meter cube. Bulk density is more than 20.80 kilonewton per meter cube, and the best suitable example is scrap iron. And for lightweight aggregate, the unit weight is ranges up to 12 kilonewton per meter cube, bulk density less than 11.20 kilonewton per meter cube, and the best suitable example is dolomite. Surface texture, that is smoothness and roughness. According to this, the classification is done as glassy, smooth, granular, rough, crystalline, honeycombed, and porous. And there are some examples for glassy is black flint, smooth textured aggregates are gravel or marble, granular aggregates are sandstone, rough textured aggregates like basalt, crystalline aggregates like granite, honeycombed and porous aggregate like brick and slag. Good qualities of an ideal aggregate. An ideal aggregate is used for the manufacturing of concrete and mortar should meet the following requirements. It should consist of natural stones, gravels, and sand in various combination of these materials. It should be hard, strong, and durable. It should be dense, clear, and free from any coating. It should be free from injurious vegetables, matters, and organic matters. It should not contain flaky, angular, and elongated pieces of aggregates. It should not contain any material liable to attack steel reinforcement in case of reinforced concrete causing corrosion of steel. Characteristics of aggregates. Important characteristics of aggregates which influences the properties of resulting concrete mix are discussed as below. Aggregate containing the constituents which generally react with alkalis is in cement cause excessive expansion cracking of concrete mix should never be used. Suitable of aggregate should be judged either by studying its service history or by laboratory tests. The size and shape of aggregate particles mainly influence the quality of cement required in concrete mix and ultimately economy of the concrete. For the preparation of economical concrete, one should use largest coarse aggregate feasible for the structure. How much size of aggregate should be used for which type of concrete is given in following chart. For mass concrete work, that is like dams, retaining walls, piers and abutments, the aggregates having size more than limited to 40 mm is used. For RCC work, that is beams, columns, etc., the aggregate restricted to the size of 20 mm and below. And for flooring, the size of aggregate should be limited to 10 mm. Properties of aggregates. The properties of aggregates directly impact on the characteristics or strength of concrete. The properties of aggregate are therefore have priority to study, like strength, particle shape, specific gravity, bulk density, voids, porosity, moisture content, etc. Strength. The strength of aggregate should be equal to that of concrete. Means if strength of aggregate is more, the strength of concrete is also more. Rocks commonly used as aggregate have a higher compressive strength. Tests conducted for evaluation of strength are crushing strength, impact strength, 10% fine test. Crushing test is more reliable as compared to other tests. Toughness by impact test and hardness is done by abrasion test. The next property is shape and texture. Shape influences the property of fresh concrete more than hardened concrete. Round and irregular aggregates are highly workable but yield low strength. Flaky aggregate requires more cement paste, produce maximum voids, and angular shape is best for the concrete mix design. Shape and texture of aggregate governs water requirement. The next property is specific gravity. Specific gravity of aggregate lies between 2.6 to 3.5 for natural aggregates. It influences strength and absorption of concrete. If low specific gravity and high porosity and therefore poor durability and low strength of concrete. Density greatly depends upon specific gravity of aggregate. Bulk density and voids is another property which depends upon particle size, grading and moisture content. A higher bulk density of coarse aggregate is an indication of fewer voids to be filled by sand and cement. If the voids are more in the concrete, the strength will be low, and vice versa. The next property is porosity. The entrapped air bubbles in the rocks during their formation leads to minute holes called as pores or cavities. The porosity of rocks is less than 20%. The concrete becomes permeable and affect the bond. The porous aggregate absorbs more moisture resulting in a loss of workability. The next property is moisture content. A high moisture content increases the water cement ratio to the appreciable extent. The surface moisture expressed as a percentage of weight of saturated surface dry aggregate is known as moisture content. Deleterious materials and organic impurities. Organic matters like clay, shell, coal, iron pyrites, etc., may have harmful or chemical effects on the aggregates, affect the properties of concrete, and are undesirable for concrete mix. Salt in the aggregate causes efflorescence in the concrete surface, and sulfide causes surface staining after concrete mixing. Alkali aggregate reaction. Before 1940, it is considered that the aggregates having inert property, but after that, it is proved that the aggregates are taking part in a reaction along with the binding material like cement. Extensive expansion and complete disruption and disintegration of the concrete is known as alkali aggregate reaction or concrete cancer. The trouble is due to reaction between silica in aggregate and alkalis in cement. A reactive aggregate, if in finely grounded state, will inhibit the action. Reaction between cement and aggregate can be of two types, that is alkalis with either silicas or carbonates in the aggregate, and reaction with silicas is common. The alkali aggregate reaction takes place only in presence of water or water vapor. The water forms strong caustic solute with alkalis of cement. This caustic liquid attacks a reactive silica to form alkali silica gel, that is AAR gel of unlimited swelling type. This diagram shows the alkali aggregate reaction. Alkali hydroxide in presence of silica in aggregate and water gives alkali aggregate gel, which causes the cracking in concrete matrix. These are some glimpses showing the cracking due to alkali aggregate reaction in concrete. Factors affecting alkali aggregate reaction. Reactive types of aggregate, that is reactive silica, have been found to have serious effect in present in small quantities, but not if it is constitutes the whole of aggregate. High alkali content of cement, if there is very small amount of alkalis in cement and very reactive silica, it is not a problem. However, the increase in alkali content greater than 0.6% of cement possesses issue of alkali aggregate reaction. Availability of moisture content for alkali aggregate reaction occurs only in the presence of moisture, which is the reason for alkali aggregate reaction is not observed in the interior mass of the concrete. Temperature conditions. The temperature should not goes more than 38 degrees centigrade, and it should ranges in between 10 to 38 degrees centigrade only to avoid alkali aggregate reaction. How to control alkali aggregate reaction? Alkali aggregate reaction can be controlled by following means: by selecting non-reactive aggregates, by using low alkali cement, by controlling moisture content, by using pozzolanas. The aggregates are found to be reactive when they contain silica in a particular proportion and fineness. When fly ash or sulky or dust is added, this optimum condition of silica being in particular proportion and fineness is disturbed, and the aggregate becomes passive. By adding air entraining agents, Alkali silica gel, which imparts pressure over the set cement gel, can be negated with the addition of air entering agents which absorb the osmotic pressure. Soundness. Soundness is defined as the ability of aggregate to resist changes in volume as a result of changes in physical conditions. The conditions like freezing, thawing, temperature changes, alternate wetting and drying. Porous and weak aggregates undergo excessive volume changes under these conditions. Thermal properties. The coefficient of thermal expansion of concrete increases with that of coarse aggregate. Any difference in the coefficient of coarse aggregate and cement paste may break the bond between the two. Fineness modulus. It is numerical index of fineness giving some idea about the mean size of particle in aggregate. The sum of cumulative percentage of residue retains on the Indian standard sieves, that is 80 mm, 40 mm, 20 mm, 10 mm, 4.75 mm, 2.36 mm, 1.18 mm, 600 microns, 300 microns, and 150 microns. Each succeeding sieve has half the aperture of previous one. Divided by the 100 is known as fineness modulus of the aggregate. The fineness modulus of aggregate is roughly proportional to the average size of particles of the aggregate. The fineness modulus varies between 2 to 3.2 for fine aggregate, between 5.5 to 8 for coarse aggregate, and between 3.5 to 6.5 for all in aggregates. The objective of finding fineness modulus is to grade the given aggregate for required strength and workability of concrete mix with minimum cement. Higher the fineness modulus, aggregate results in harsh concrete mixes, and lower fineness modulus results in uneconomical concrete mixes. Now, in this session, we have discussed about various types of aggregates, coarse aggregates, and their properties. In next lecture, we will discuss about various tests to be carried out for finding out the quality of coarse aggregate. Thank you.